before the start of the video, I wanted to show the end result that we're going to create, which is viewer state, and this is the code for it. And the end result should be the fact that we are entering this viewport state, and we are basically changing the cusp angle of one of our parameters, like that. So this should be the end result. This time we're just creating a single digital asset and changing the normal cusp angle from the viewport. And we also get some neat widget that actually shows what's the normal angle at it. And also we implemented this drag ratio, which is going to calculate how big of a distance we have to travel with the mouse to change the cusp angle. Basically how fast it's going to change. So in this video, let's talk a little bit about the viewer states, where to find them, and kind of a little bit of demystifying them, where to find some examples, and how to read maybe already created viewer states. And let's start with the intro, and then we actually going to start creating some of our own viewer states. So this video is going to be kind of introduction and then a little bit more advanced stuff. So it is in Python, so it is kind of a little bit of a basics of Python is required. So, but I mean, it's not very complex Python, so if you know a little bit about it and know the basics of object-oriented programming, let's get started. Let's start with the most basic setup. Let's put down a subnetwork, and let's create a digital asset from it. So in here, I'm just going to point it to my HDA global variable. You can put it whatever you want it, and I'm just going to do it your state test, and maybe I had already test, so I'm going to just put it to accept it. And now we have our digital asset. Accept it, and let's just point a box at it, and that's it. So let's go to the type properties, and first of all, before writing any kind of a viewer state on its own, let's actually point one of these viewer states to this digital asset. So what we can do is actually go to the node, and in this default state you can actually point the name of these already completed viewer states. But since they're obviously not going to work, since they're not made for our empty viewer state, but let's just point at some of these. So maybe let's point the ruler to it. So ruler is the subcategory, and it's just called ruler, but it's also called labs ruler. So let's point it. So basically we have to point to the type of it. So the label just for us to read, but actual file that its file's name is labs ruler. So let's point it to it. Labs ruler. Let's apply it, accept it, and you can see. So since you're inside, you see it's going to throw many errors, but that doesn't really matter since we have shown that we have actually successfully pointed to it. So you can see that in this ruler, you can see we have our ruler text that has to be, but since it's not made for our HDA, it's going to throw up multitudes of errors. So that doesn't really matter, but we have pointed successfully this ruler to our HDA. So this is how it works. So, but obviously we probably want to create our own custom HDA. So let's go back inside here and let's delete this ruler reference, and that's it. Now it's not assigned anymore, so it doesn't give us any errors. So now let's actually create a viewer state. So first of all, we can do it from the HDA or from here. So since I always do it from HDA, and that's why I think it's actually a better way to do it. But actually, let's take a look at how can we create a viewer state from here. So first of all, we have to actually select what context you want to run the viewer state, since it's actually not gonna allow us to pick a new state. So just go to the sub level and then just a new state, since we are working in sub level. So let's create, and this is basically the same menu that's going to be offered also in HDA. So in here we have to give it a name, a label, basically just a name, because label is going to be automatically generated. If we want it unique, then sure we can change it, but You can see this is basically all the event handlers, which basically, these are basically a methods inside Python that's going to be run whenever it happens that you want this viewer state to be. But actually, let's actually not do any of these. So the UI is probably the most. We're going to work with this UI. But now let's just click on blank, and this is going to be, let's call it, let's call it YouTube. Actually, I'm going to call it as my username on this PC. Let's call it YouTube tutorial, and just in label, let's point it as this one. Let's create it a blank viewer state and accept it. So you can see it's basically created the most basic viewer state that it can be. It's just a class, and this is the mandatory entry. So this is basically a different method that is basically needed for us to create this viewer state. I'm gonna show it a little bit later, but it's basically there's no even any methods that is actually going to run on this viewer state, but that's fine. And just accept it, and let's find it. You see, now this is actually inside our viewer state list at the very bottom, and you can see that this is just a Python file on Houdini. In Houdini on disk, basically we can go ahead at this location and just edit it there. So, but let's actually go ahead and let's assign it to our default viewport, default state. So I think I have it copied. Let's apply it. Let's enter it. You can see we have this YouTube, and you can see it basically does nothing because, well, it's just an empty viewer state. But we have successfully created our own viewer state, and we can actually enter it without any errors and do whatever we want with it. So this is one way to assign a viewer state to it, to our HDA. So this is one way we can assign our viewer state to our HDA. But actually this is not preferred way because we can actually in real time actually change the Python code and then see the results of it. So and use our own editor that's, it's much more advanced than this one. So you can press on editor on viewer state and press on edit, but then you have to press on edit text in external editor, so it's kind of a pain to do it every time you update it and all of that. So the best way to actually assign our viewer state is through the properties. So go to type properties. So make sure you clear out the default state so it doesn't call this viewer state. We're actually going to embed our viewer state inside our HDA. So go inside interactive and just press on new. You can see it's basically the same menu as inside here, but this menu is going to basically stored inside our HDA and not on a Python file on a disk. Of course, it's going to be embedded inside HDA. So I'm going to call it YouTube tutorial HDA. So make sure it's not the same name as any of your already created viewer states. So that's going to throw up an error. So you're going to press and paste it the same label, maybe without the underscores. So we have a little bit different text. So we can actually take a look at how it looks like. Actually, with the also uppercase first one. So, and all of these samples are, let's actually not do blank, press on blank and make sure you have these, all of these, and that's it. Accept it. And now we have, you see all of these selections that we took. We have onEnter method, onExit, onInterrupt, and you see it's also, there's a little bit of a text that it says what it actually does. So, and on MouseEvent is basically whenever we move our cursor inside our viewer state in our scene viewer, so we can get a bunch of good data from it, and then just apply it, accept it, and that's it. And now we have, you see, we have our second viewer state. You can actually see it should be actually loaded also inside our viewer state browser. You can see whenever you enter the viewer state, it's going to become green, and just press on this plus. You can see if you take a look at where it's located, you can see it's basically located inside my HDA, and this is my HDA name. So let's take a look at it. So this is basically my, like, I guess I didn't really So basically this is my HDA names, it's the same location as this viewer state, so it's basically embedded inside here. And now that we have embedded our viewer state inside our HDA, let's take a look at actually type properties and go to the wherever we wrote inside our nodes. You can see it's basically automatically assigned this HDA to our default state, like where we manually wrote in this any of these names. You can see it's automatically wrote in at the default state, so that's really nice. But the biggest advantage is actually that we can now actually edit this code. So I think this is you can see we have extra option, edit extra section source code. So I think this is from the labs, so you don't need to install labs. So but since it's free, and I think it's even comes now with comes with every install of the Houdini, so there's really no excuse not to have labs installed. So just go size here and press on extra section source code. You can see we can pick any of these, and what we want to do is edit our viewer state module. Press on it. You can see it basically going to automatically open whatever we have set up as our external editor in our Houdini global variables. For me, it's a Microsoft, what is called, a Virtual Console, or whatever it's called even. It's Visual Studio Code. So this is where I have my editing, where I do all my editing. It's basically going to automatically add this one, and it's gonna give us real-time editing options and seeing results of our code. So let's take a look at is it working. So let's go to the open up Python shell, and let's go to our code, and actually on enter, let's actually just print out some text. Let's print out, this is printed out. So now enter it. You can see it's immediately we have this printed out on enter. So since we have entered this on enter, it's basically going to print it out once we enter our viewer state. So this is the way to do it. Really, it's really awesome that we can actually real time seeing the results of it, and yeah, that's really cool. Now that Houdini has created our template, let's take a look at this code. And first of all, let's go to the debug menu, and how can we actually get some information and get some feedback from our code and what we are doing in it. So first of all, let's press on enter inside code, and let's actually press on this trace event handler. You can see that Houdini will actually return the function that is actually running right now. Since we have like on MouseEvent, on exit, on interrupt, and on resume, you can actually see when these functions are actually called. So you can see once I'm inside my viewer state and I move my mouse, you can see the MouseEvent on MouseEvent is called, which is this function. You can see I go outside this one, you can see the mouse on interrupt is called, and then on resume should be called. You can see on 6731 on resume is called, and then if I enter it, you can see on exit is called. So you can see what functions are when called when we use this very useful trace event handler. So this is very nice. Now that we checked out the trace event handlers, let's check out the inspect active state. So let's just go inside our state and let's press on it. So there's going to be a bunch of information about the active state, but the most interesting is the handlers. So you can see that these are all the methods that actually Houdini is going to recognize as the methods that it can work with the event handler. You can see on enter, exit, on interrupt, and all of these. So obviously in our viewer state we can create our own methods, and we can then pass them to our any of these and all of that. So let's actually write something, and just let's create an empty method. Let's just pass it, and also let's create the one of the method that is recognized by Houdini. So let's just go to the, let's just get some of these names. It doesn't really matter. Let's put it on command. Just let's create our empty, as long as it's the name of it that it's actually going to recognize. on command, and it's probably going to be just a self and quarks. That's Houdini gonna give it. Let's just pass it. So now we have two. Now we have two methods that we just created, which is the food that is just our created, and this is one that Houdini is going to recognize. So let's take a look at it. Let's enter it again, and let's go to the event handler. You can see in handlers, you can see on command is actually recognized as a handler, but our foo method is actually not, because, well, because that's our own method and we can do whatever we want with it. So, and remember that all of these commands actually always going to give out the quark dictionary. So this is basically information about this state that we just called. So we can always print out the quarks dictionary and any of these, and it's probably, I mean, I'm pretty sure that all of these are the same as with the argument that we have to give it, which is the self, which is the instance of this method, and the quark dictionary that's actually Houdini is going to write in, so that we get some context on this method that we need. And probably the most useful one is this debug log, which for the longest time I just used the print command to print information about some of the variables, and if I'm getting the right information by printing out on Python shell. But actually this is a much better way to do it. It's basically a log system. So you can see that by default there's even some of the things that it's already printing out. So you can see, let's say on onMouseEvent, let's uncomment this one. You can see it's basically using syntax of self.log, and then in parentheses we just write in any of the variables or values that we want to be printed out. So this we are basically taking a devices, and it's printing out the mouse position X and Y, and if the left button is pressed down. So, and then now that we have uncommented, let's go inside it, and you can see every time this method is called, which is onMouseEvent, which is just a moving of the mouse around inside scene viewer, you can see it's printing out the position of the mouse. You can see basically it's on only for the scene viewer size. So you see if I'm here, it's basically 0, and this is going to be the max value. So, and then we also, if we are pressing down the left button, so let's press it down. You can see I press it down and moving around. You can see it prints out true. So this is very nice for the debugging purposes, to know if we are doing actually writing and getting the information that we need. So obviously we can print out anything. So let's say on enter, let's take a look at enter, and let's actually print out something. So for this, that's actually that by default it's actually going to, oh my bad, it's actually going to print out the quark dictionary. Also the quark dictionary is very nice. Actually let's uncomment this one so we do not get all this. Actually the quark dictionary is very nicely readable inside here. So you can see that every dictionary value is kind of on the side, and every value in it is kind of a little bit of a tabbed out. So let's say I want to get my node value. You can see it's a key and there's a value of it. It's just a object for our node, basically object for our node reference. And now let's just create one quick viewer state which is going to control our one of the parameters of HDA. So what I'm going to do is actually, let's create actually a new subnetwork, and what I'm going to do is in it I'm going to put down a normal. So it's going to be just a normal node. We are basically going to scrub the cusp angle for the normal inside our viewport, and that's it. And let's create a digital asset. So I'm going to put it in my HDA path, so make sure that you can actually find it when we open up a new scene. So I'm going to call it normal scrub, and that's it. So now for the parameters, I'm just going to go inside here. I'm just going to drag and drop my normal node so we get all of the parameters automatically assigned to the it reference outside our network. So and that's it. And now let's just put in some, test it out. Let's put it on peak head, and now you can see actually I have a flat shaded, so smooth shaded. You see it's basically the same, but from top of same functionality, only from top of the HDA. And let's say you want in viewport control this normal. So this is going to be base for our maybe more complex HD viewer state in the future. So let's just do the most basic for this video, and then let's see how it goes next time. To see what effect we are going for, let's open up a new window in Houdini, and let's press on open and go to the HD global variable, and this is where we have actually some of the viewer state examples. So press on viewer state examples, and from all of these we want to take a look at the scrub demo. So this is basically almost everything that we need for us to create our own viewer state. So let's take a look at how it looks like. So press on this and go enter. You can see in this viewer state we are getting the cool widget above our mouse pointer of which frame we are on, and you can see it basically scrubs the frame. Let's go inside here, and let's actually start with take a look at the code. And just make sure that you have opened this one when we are going to edit our own, so we have this also here. So I think, well, let's keep this one open. Let's go to our actual HDA, and now let's create our new HDA. Since we created the new HDA, our viewer state is going to be empty. So just like before, let's create a new one. So let's think about what we will need. So we're probably gonna need onEnter and onInterrupt, onExit, and onResume also. And let's pick also the mouse event like that. So we can also take a look at this example that we just opened from the scrub demo. You can see the methods will be different, a little bit different. So you can see there's onGenerate, but we won't really need it, since onGenerate is called only when we call this viewer state from the nodeless state. But obviously we have a node, so we won't need it. But we still gonna want to text on the bottom, since many of these, since most of the tool viewer states actually has a little bit of information about the actual viewer state. So what it actually do. So we want actually some text underneath, even though we won't really write anything all that useful, but we still want text underneath our viewer state. So let's just pick these and onMouseEvent, and that's it. So let's take this one bottom, and also let's call it, I'm gonna call it something like normal scrub. I hope. Maybe I have already that name, so I'm gonna actually just call it v2. So just paste it and maybe some caps for the label, something like this. And alright, that looks good. Accept it. So now we have our viewer state. Apply it, accept, and let's open up this one in our external editor. Alright, so now we have our editor opened up. So let's actually start cleaning up some of this stuff. So first of all, let's start only with let's clear out any of these logs. Make it a little bit, and also this comment, since we know what it does. Let's just delete it. On exit, so that our code is not as cluttered. So on interrupt, let's clean it out, all of it. On mouse event, you know that. Also self log. Let's delete all of these. So let's not touch this one. And all of these going to be pass. That looks good. And to make sure that it's actually working, let's actually on enter, let's print out our quarks in a quarks dictionary in our viewer state browser. So let's do that. So it's self.log quarks. Let's open up. You can see it's working. We print it out, so that's very nice. And now we have our live connection between this file and our viewer state. First, let's create a global variable that is going to be our message, so we can reference it in any of our methods. So let's just call it message, and let's just call it. So now we can reference it in any of our methods because it's basically a global variable. So it's outside any of these. So for our init, in init it's a good idea to start initialize some of the values that we will use across all of these methods. So we can always call it. So even though right now we're not going to give them any values, it's a good idea. You will see that in many of these example files, you can see that many of these variables are actually initialized with a none. Basically, there's no value for it, but they are initialized. So we're gonna do the same thing. So first of all, what we want to do is actually, let's think about what we actually want to do. So we want to take our mouse position, save it, and then we want to calculate the distance between the start of the drag and then once we have clicked our left button and how far we have actually dragged this mouse button across on positive or negative way, and then we just basically want to add this value to our cusp angle normal. So what we're gonna need is actually to get our start position and our start position of our mouse pointer, and also the angle of what's the value of this our normal when we start to drag. So let's start initialize them. I'm going to do just self.start position, and you will notice that something like here you'll see that it's very nice way for us to assign none to multiple variables. Is basically say base x equals and also then the same one and then the none. So basically with one line we can actually assign multiple variables, assign the same value of none. Then we want to I'm going to call it a start normal. Well, I mean it's a little long, but whatever. So that's that. And now let's take a look how can we actually get this cool widget about our mouse pointer. So if you take a look at this demo, scrub demo, if you play around with this code, you will notice that you will soon realize that this pointing label is actually what creates our cool widget about our mouse pointer. So first of all, what I want to do is actually take all of these, and actually import it, all of it, from our demo to our actual demo, actual viewer state we are working on. And what I want to do is actually for the init method, actually copy all of these for the. You can see that it's basically creating variable pointer, and then it's assigned this pointing label, and then we run bunch of functions on it. We're basically setting it offset, the fixed width, and orientation. So just copy all of these and paste them inside in our init, just like that. And let's actually add maybe one space so we can easily see separation, and that's it. So you will see that immediately this is going to be as imported. It's basically going to be lighten up. Let's comment out. You can see now it's grayed out, but see already we are using two of these imports. It's always good to take a look at where we're actually using these imports. You can see it's Qt, show without activating, and pointing label. And for us to know why are we exactly importing all of these libraries, we actually have to, this goes into the territory of the Qt, which is, I mean, this is way out of this tutorial scope. But in summary, Qt is just a development framework written inside C++, but there's a bunch of wrappers for it, for us to use it in Python. And this pointing label is actually basically it's a class which parent class actually some of these Qt libraries for the Python. So basically kind of a kind of tailor-made pointing label for the Houdini. So I mean, it's a huge topic, UT. So I mean, you can start to look it up all of these in Google and start kind of working backwards and see where these are actually coming from. And this actually pointing label, you can actually find it inside the Python 3.7 library on Houdini install file. So you can take a look at it, what it actually does. Now let's start looking at our onEnter method. So I did a couple things. First of all, I deleted everything unnecessary and saved only the self.node, which is basically a reference to our node. So we can access all of these parameters and all of that. So after the node, what I did also is actually created a new parameter for our HDA, which is going to be a drag ratio. So go ahead and create a float parameter. I call it drag ratio, which basically dictate how fast will our cusp angle change when we actually drag this. So what's kind of amplitude for us to drag it. So you want it bigger or smaller. So we can even extend it to all of the screens. So but basically because there's a bunch of different screen sizes, and since it's counting pixels that we actually move, so for our convenience we can just tune it how we want it for our drag ratio to be. So that's that. So but first of all, let's get references to some of our parameters. So let's get reference to our, since we are going to change this parameter, this cusp angle, we actually want to just a quick reference to our cusp angle parameter. So that's going to be, let's call it self that normal parm equals self that node dot parm and its cusp angle together. So that's cusp angle. Now we probably want to onEnter just one time, want to get our drag ratio. So since it's not something that we're going to change very frequently, and if we do that, we can just enter it, exit it, and enter it again. So let's just get our drag ratio. So that's going to be self.node, the same one as here. Let's just copy it, and instead of the parm, it's a drag ratio. And since it's just a reference to the parameter, we want to actually evaluate. So it's just eval. We also can eval as a float, since it's a float, but I just use eval and these two, and also let's actually get our message initiated when we enter it. So at the very top, let's get our scene viewer object and let's set prompt message. Like that, and let's reference our global variable message. So we can either say self.message like that. So let's take a look at it. So you can see now at the bottom we get our message. Or we can actually reference the entire class, which is state.message. Like that. Since it's a global variable, we can access it just by state.message. It's the same thing. So I think we're done for the enter for now. Actually, let's check it out if it actually works. So let's reference all of these inside one of the in a log. Now let's take a look at it. So you can see we are normal parameter, we are referencing normal parameter, and the value of our drag ratio, which is 0.506. You can see we are getting these values correctly. So let's delete it, and now we're done with the enter. So let's probably go ahead on onMouseEvent, work on that one. And now let's take a look at onMouseEvent. So first of all, let's print out the quarks and take a look at it, what it actually gives us information. So the most important thing that we can actually get from it, well, there's something duplicating, something like a node reference. We can also get the node reference from onMouseEvent, but since we are not going to really change the nodes while we're moving around since you're not going to change the node while we're moving around the mouse, there's no really point for us to reference it in here. So just do it on enter, do it once, and that's it. But the most interesting part is this mouse.x and .y, which is basically a position of the inside our scene viewer of the mouse, like that, and also the reason. So reason is basically, let's take a look at it on help. So in reason it's a module which is basically being called whenever we are doing something. So let's say we have left mouse button is pressed. Basically when we have pressed it, it's calls to start. When we drag it, it's active. When it changes, when we basically release the button, it's released. So we can use all of these as kind of a checks on what kind of values you want to actually save for our variable. So we're gonna use this method to create our drag, and now let's just create a variable with reference to our reason method. So if you are sometimes confused where exactly how can we get reference to some of these values, well, just go from the top of it. So you can see that this UI event, since this quark is always a dictionary, these are basically the keys. So state name and all these are keys. So for dictionary, how do we access keys? Well, it's with the square brackets. So let's call it reason equals quarks, and then we want to, in square brackets, since the keys are always the strings, UI event, and since you can take a look at it, you can see that this UI event is actually going to return the class who.viewer event. So what you can do is actually just go to the help and find it UI. So basically find the who.viewer event. And so just paste inside here, it's gonna find it. You can see all of these methods, and we basically just access them like a regular method with the .device. So UI event dot device, and that's it. And so let's print this, let's delete this, and let's print out our only the reason variable. Oh, it's not a device actually. Oh, my bad. It's actually the reason. That's the wrong one. There we go. So you can see we are now getting a different call depending what I do. If you left click on it, you can see it starts, change, and active. So this is exactly what we need. And since we only going to access this reason within our onMouseEvent method, we don't really need to call it self.reason. So we know this works actually. Let's leave it at the very end so we can print out later some of the values. So let's leave it. So now that we have our values, so now what probably want to do is get our mouse position. So but we have one problem. So since we did so that actually this quark is actually going to print out our mouse position, but the problem is that it's actually going to print out mouse position relative to this scene viewer, and not the actual within of our screen. So that's a little bit bad because we actually want to, if you take a look at this scrub demo, you'll see that actually it's getting also the values of the pointer values. So let's take a look at it on onMouseEvent. You can see that this Qt graphic user interface actually used to get the Qt cursor position. So which is basically the global position within our screen space, and not only the scene viewer, which is called by the quarks from the onMouseEvent method. So we actually want to use this one. So let's just copy this one, and let's just put it down here. So this is going to be our position, and actually we can print out our position. So you can see we are now getting this position, which is actually the global position on our screen, like that. So this is good because we actually have to assign this also to our pointing label later on. But first of all, let's work with this one. And since we're going to need both x and y values, actually let's create two different variables for x and y. So what I'm going to do is just call it position x, then and the position y, and it's going to be just pos dot x and pos dot y. So these are methods within the Qt wrapper, so you can find them easily on the internet. So, but just because actually I think it's actually being used also in here. You can see basically being the same thing as here. Basically we are getting different values for each axis, and then we are just pointing them. So let's just go ahead and copy all of these from our scrub menu. Let's copy them and let's paste them inside here on onMouseEvent. And all we really have to do is change the variable names, since we are going to use them also for our calculating of the difference. So we want to create a variables from it. So we don't have to call it every time position.y. So it's usually a good idea if we call some of these values more than once, just create a variable from them. That's it. And you can see that also the text of it is actually for this it was a who.frame, the frame value, but for us let's just call it foo for the placeholder, because we're not adding any value right now. Let's actually delete this one to do also like that. So let's take a look at it. So you can see already with this pasted code, you can see we are getting our following of our mouse cursor with this widget. This widget is following it. So this works very nicely. And now let's actually start working on our UI reasoning. Now let's quickly check out these position x and y. So let's write them inside our log. Position I and position y and x. So you can see they are working. That's good. So let's start calling some of these values from our UI reason, which is here. So first of all, if reason equals, let's take a look at this help. Let's just copy them. So first of all, we want to start with if the UI reason is start. So if we press our mouse button, so you will notice this. Let's just copy it. If this is equals this one, but now let's just pass it. You will notice that this start is actually let's print out to see when it's actually being called reason. So you see that this start is actually called for a very brief time. So I just press on it. You can see it's pressed and just activates one time, and then once I start dragging it, it becomes active. And if I click it, you can see it's start and then it's changed. So this is a very nice time for us to set up our initial position for our variables that's going to be called when we actually want to get the difference between the start value and then the value that we are dragging to. So for this start, let's start with the self.start position. So we did created it with here. Self.start position is going to be basically the start of the position.x. So since we are dragging on x-axis, just copy this one, and that's it. So this is going to be ran only one time, and then when we actually going to delete it, we can actually put it back to the none. But actually we won't really need that, so this is good. So basically we have frozen this value at the very start of the event. When we press on it, this value won't gonna go up, because this is called for a very brief time. Basically one time when we press it, that's the only time when it's called. And then we also want to get the value of the start normal value. So basically at the start we want to also get the cusp angle. So this start.normal val is the this is exactly why we actually created self.onEnter. We actually created self.normal parameter reference, and then just copy this self.normal parameter reference, and then we just want to eval it. And now we have our value, and this is basically the only thing that we want to get from start of this UI event. So let's actually print out these values. Start position, and let's take a look at it. So you can see I press on it, and then I drag it. You can see this value is not actually changing. And when I click it again, you can see it updates it, but it doesn't goes anywhere, because every time I click it, it basically resets it at the different. Since this UI event is actually run again, it basically gets a new value every time I click on it. And now let's work on our who.UI event active. So let's just copy it, and let's call it the active. So this is when we have pressed down the left mouse button and we drag it around the viewport. So first of all, since we only want to, let's pass it. So first of all, since we want to only get this widget above our mouse cursor when we are dragging it, let's just take all of these mouse pointer locations. Let's call it only when we are actually active UI event reason. Something like this. So now only when I press on it, it's actually being displayed, and you can see that actually it's when I let it go, it's actually going to not disappear. That's because we actually have to put in another UI event reason which is when they actually let go of the left mouse button. So let's just copy it, and if the reason is it's called changed, all we have to do is tell that pointer not show but hide, like that. Let's take a look at it. So you can see now I drag it, I let it go, it disappears like that. This is exactly what it went, but let's actually do all of the kind of mathematics of it, of the displaying of the actually dragging of the values of it. So all we have to do is calculate the distance between the value now that we have dragged and the start value. So let's call it something like let's call it the distance. And in distance, all we have to do is from the current position, which is the position.x, we want to subtract the self.start position that we just created on top in our start, like that. And let's actually print out our distance. Let's take a look at it. So you can see we are getting basically the distance between the value of a current position and the start position. So if I go to the positive, it's positive, and negative, it's negative, like that. So now we have our distance, and now what we have to do is set the value. And since we are actually going to use this set value as our set text as a string for our widget, let's call a variable which is the value to set. It's going to be basically we have to basically get the current position of our normal value, which we got at the UI event reason start. Let's just copy it, we want to add a distance. We want to add distance to it, and after that we want to also integrate our drag ratio. So we want to basically multiply our distance with our drag ratio. And let's just multiply it with the self.drag ratio. And since the multiply is going to be done first, this is going to work just fine. And now all this distance, only thing we have to do is actually set it. And self.normal parameter reference, which we created, and then we have to do it, just set it to dot set value to set, and this should work just fine. Let's take a look at it. So you can see we are changing it. So let's stop actually the logging of it like that. So you can see we are now dragging our cusp angle like that, and let's put in our drag ratio to very low. Let's enter it again. You can see now I have to really drag around my display to make a bigger difference for our normals. So we'll just make it maybe something like this. Re-enter it. This is a lot nicer now. Now let's clean up some of these values. So first of all, you will notice that our cusp angle now is actually the float value, and also you can see that our widget is actually displaying huge numbers. That's because we are actually getting a float number from all of these values to set all these multiplies and adds. So let's just typecast it as an int, and that's it. We should now get the nice int values for our normal, like that. Now these are int, but one problem is that even though we can go below or above 180 for our cusp angles in this parameter, you can see we are actually printing out bigger values. You can see it's actually prints out negative and positive values. So what we can do is actually wrap this int around the max and min functions, which is basically always going to return the biggest or the smallest number from the list that we give it. So put in the max and just wrap it around all of these inside it. And since we want to get the biggest value, so between this value, whatever we're gonna get, and 0. So this is going to be 0 if we have negative values inside here. So now you can see that this widget is never going to display a smaller numbers than 0. And basically we can do the same thing, wrap it again with the min. And with the min, we know that the maximum value that we want to display is 180. So just put in 180 again, like that, and that's it. Let's take a look at it. So you can see it's not displaying above 0, and let's go up. You can see it's not displaying above 180, our widget. So this is how we can fix this problem. And one last thing, let's actually fix this message that we create underneath. So you can see our message works at the start, but when we are on interrupt, it's actually going to disappear, but it's not going to actually reappear. So what we could do is actually on interrupt, let's actually hide our message. So which is basically instead of let's find our message where let's set prompt message. Let's just copy it. So on interrupt, we want to hide it. Instead of set, it's going to be hide prompt message. And on resume, we want to again show it. Self.show. And on exit, we probably want to. So what's the exit happening? State params. On exit, we want to when we exit, we want to actually hide so this, we won't need this one. We just want to hide our prompt message. So let's take a look at it. So now we are on, I'm pressing Alt. I am basically calling the onInterrupt method, and when I press back, which is called onResume, you can see our message is being showed again. And when we exit it, it's just going to disappear. So this is going to fix our message like that. So obviously we can also work a little bit with these values, fix width. So maybe instead of 50, 100, let's say 50, you can see now our window is a little bit smaller since our values are not that big. And we can also put offset, but what I want to do is we can actually also play around with this point down. Basically, where are these pointing from? So where this kind of like this bubble pointing at? So you can see now it's pointing to down. So let's write point left. Now as you see, it's pointing from to the left side, but actually like it from the down like that. That's it for this video. Hope you found something useful in it, and make sure you save this HDA, and maybe in next videos about the viewport states, we're going to use this as our base for something more elaborate. So that's it for this video, and see you next time. Bye bye.